Hello, beautiful viewers. You're welcome once again to another fascinating math video. It's been quite a while now. I must tell you the truth, I've not been fine health-wise, but thank God today I'm okay. So I hereby present to you another video, but this time around we are looking at problem from analysis. I would still like to add that if you are in need of a private online math tutoring service, it can be private or group, whichever is the case, be very free to get across to me via my WhatsApp number or you message me directly because I render exclusive service when it comes to this demand. I have an ample experience on tutoring various level, high school level, secondary, primary school, even to the university level. All right, so be very free to get across to me for such a service so that we can make arrangements regarding how the class should be organized. So quickly go over to the solution of this particular problem. Over here, we are given two functions, and these functions are defined piecewisely. The first is f of s equals to 1 minus x for x less than equal to 1, while the other part of the definition is 2s minus 1 for s bigger than 1. That is all for the function f. Then over to the function g of x, g rather. G of s is equal to 0 if s is less than 2 and equals minus 1 if s is bigger than or equal to 2. So we are required to find the sum of the function f plus g and the domain of that sum, also the difference of the function f minus g and the domain of the difference. And lastly, we are required to find the products of the functions and the domain of the products. All right, that is the first part of the question. Then number 2, we are required to form the composition f composed with g, or you simply read f circle g, and we are to give the domain of the composition so formed. All right, so let's look at the first of the problem. First of all, we bring down our functions. Solution. We are given that f of x is equal to oh, this is not well drawn. All right, we can manage this. We have 1 minus x for x less than equal to 1. X is less than or equal to 1, all right? Then we also have 2s minus 1 for s bigger than 1. Then the other function here, we have g of x also defined piecewisely as we have 0 for x less than 2. Then we have minus 1 for x bigger than or equal to 2. All right, so one thing you should understand, in trying to find the sum of functions, we must determine the domain. When dealing with function, domain is very important. Many people deal with function blindly without considering the domain of the function. All right, it is very important to consider the domain of a function when dealing with function. Now, if for us to find the sum g plus f, or you say f plus g, whichever, we must consider the domain of the function g and f and look for the intersection of the domains. Because if we have a function f and we have a function g, in order to find f plus g must be defined on the domain. In other words, the domain of the function f plus g is equals to the domain of f intersects the domain of g. That is, we must look for the intersection of these two domains of function f and g. and the intersection will define the domain of the sum f plus g. All right, so we must do that. So how do we go about that here? If you observe carefully, the function is piecewisely defined. All right, first of all, let's locate the domain of the function f. Now take note, we can say the domain of the function f is equals to the set of all x such that x is less than equal to 1 union the set of all x such that s is bigger than 1. You can see that here. Can you see this? Look at this. This form the first set and this form the second set. So the union of these two sets, which is this, will be the domain of the function f. Writing this in interval form, we can have it as, since s is less than or equals to 1, we can have it as a minus infinity to 1 inclusively. All right, the union, the same thing happens here. Since s is bigger than 1, that means we have 1 exclusively to infinity. So this is the domain of the function in interval notation. All right, so we shall break up this domain such that the function f and the function g will have intersections for which the value will be defined. All right, so let us look for the domain of g first. Let's look for the domain of g before we do the breakup. Now, domain of g is equal to writing. Now, in this case, we can say a set of all x such that s is less than 2 union set of all x such that s is bigger or equal to 2. Now, writing this in interval notation, we have the result as since s is less than 2, we have minus infinity and ending as 2 exclusively union. Now s is bigger than 2, that means we start from 2 ranging to infinity. All right, so we have these two domains at hand. So what we shall do, we shall define in order to get the sum, please take notes. This you see here can simplify to writing minus infinity to infinity. All right, why this can also simplify to writing minus infinity to infinity. So in effect, the two functions have the same domain. All right, can you see that? Now, how do we get the sum? Okay, now observe the first function carefully. This over here, observe this over here carefully. All right. Now, if you observe this function, you will see that the value of a possible value of the function is 1 minus x, and that holds when s is less than or equals to 1. In other words, when s is in this domain, look at it here. Can you see that? When s is in this place, that is 1 to infinity. Now, looking at the function g, we can see that there is an intersection between this interval and this interval. And what is the intersection? The intersection is simply this. All right, the intersection is simply this. Can you see that? Because this you see here is common to this, and this is included in this interval. If we are to represent in a number line, for example, let me represent so you can get what I'm talking about. Let's say this is a number line now. Let me use this side. This is a number line, right? Then we have 2 as a result here, and we have 1 as a result here. Now, since in this domain G, since s is less than 2, we can draw the number line as follows, and the arrow will point to the left, right? This shows that x is less than 2. Then, since in this one you are seeing here, since x is less than or equals to 1, we can have it as follows. Then you can see that this region is a common region to both of them, and this region defines x to be less or equals to 1. So in other words, the intersection between these two intervals is s less than or equal to 1. All right. So that means both functions will be defined on the interval s less than equals to 1. Hope you get what I'm trying to explain. Please try and get it. It's very, very important. So we can say on the interval x less than equals to 1, both f and g are defined. All right, both are defined. So in that case, we can say for all x that comes from the interval, which is this you are seeing here, which can be written in notation as minus infinity to 1 inclusive, f plus g of x is equals to writing f of x plus g of x. That is the definition of the sum of functions. All right. Now, on this interval you see here, if you look at the function defined in piecewise form, you see that on this interval, the value of the function is 1 minus x. All right. So I can come here and write for f of s, I will write 1 minus x plus. For g of s, under the same interval, coming to g of s, don't forget s less than equals to 1 is contained in this interval. Don't forget that. So on the same interval, g of s is 0. Look at the value here. Can you see that? So I can come over here and write 0 in the place of g of s, and that will leave me with 1 minus x. Hope you see that. So we have gotten an expression on this particular interval. Let's look at another interval again. There's still a common interval. Now, once again, look at this interval also. X is less than equals to 1. All right. Okay. We can't take that any longer. Let's take this. Let's take s is bigger than 1, and s is bigger than 1, and s is less than 2. You see that there is a kind of intersection. Yes, if to see that, you can draw a number line. You see there's an intersection. Look at this. We have this one. Let me draw this. You see, we have this as 2, and s is less than 2 means the arrow will be going this way. All right. This s is less than 2. We have 1 here. Can you see that? The s is bigger than 1 means the arrow will be going this way. So that this region is a common intersection point. All right. So we have the function being defined on the interval 1 is less than s and less than 2. Can you see that? So if we come over here, we can say for all x which are in the interval 1, sorry, this is not inclusive, exclusive. I will remove this brackets. 1 to 2. On the interval 1 to 2, we have that f plus g of x is equals to, we still have it as f of x plus g of x, because that is how the sum of functions is defined. All right. And this is equals to writing, now my f of s on this interval 1 to 2, my f of s is what now? Don't forget, let's go to f of s. F of s will be 2s minus 1. Don't forget, we are considering s bigger than 1 and s less than 2. We are considering the intersection between them. I will find the intersection to be this. All right. So on this interval, a possible value, I mean on this common interval you are seeing here, the function will assume the value of 2s minus 1. All right. We assume the value 2s minus 1. Why? On this the same interval, the function g will assume the value 0. All right. So I can still come here and write in the place of f of s, I write 2s minus 1, then plus 0, and that will give me 2x minus 1. Can you see what I'm doing? Then we have considered that interval. The next interval we'll be looking at is let's take, now you know that looking at this interval that this s is bigger than 1 and s is bigger than or equals to 2. Looking at these two intervals, you see that the interval s is bigger than 1 is larger than s is bigger than or equals to 2. In fact, s is bigger than 1 contains s is bigger than or equal to 2. If you observe carefully, you see that. All right. So in that case, the intersection between these two intervals will be s is bigger than or equals to 2. All right. So both functions will be defined on that interval because s is bigger than 1 and s is bigger than or equal to 2 have intersection, and the intersection is s is bigger than or equal to 2 because that interval is contained in the interval s is bigger than 1. All right. So in the interval s bigger than or equal to 2, both functions are defined. So I can come here and write, I can say also for all x that comes from the interval 2 ranging to infinity, that is s is bigger than or equal to 2, we have that f plus g of x is equals to writing. Now it's also the same thing, f of x plus g of x. Now my f of s is already in on that interval. My f of s is 2x minus 1. All right, so I can come here and write 2x minus 1 plus my on that the same interval. My g of s is what? Minus 1. So plus minus 1, and that will give us 2x minus 2. All right. So in this way, we have got to the sum of the function. Let me add more page to the work. So I can say therefore, my f plus g of x is piecewisely given as the first value of it is what is the first value? 1 minus s, and on what interval? This interval. All right. So I can come here and write 1 minus x for all x that are elements of minus infinity to 1 inclusive, minus infinity to 1 inclusive. All right. And the second value of the function is 2x minus 1. So I can come here and write 2x minus 1 for all x that comes from the interval 1 to 2 exclusively. All right. And lastly, on the value of the function, the possible value of the function is 2x minus 2, and that is for all x that comes from 2. Let's put elements here that come from 2 to infinity. Hope you can see what I'm doing. So we have defined this function in piecewise form. If you don't want to use this interval notation, you can write it as 1 minus x for this is s is an element of minus infinity to 1. For s less than equal to 1, it can be written like this, the same thing. All right. Then we can have this one as 2x minus 1 for 1 less than x less than 2. And lastly, we can have 2x minus 2 for s bigger or equal to 2. All right, it can be written in this form. They are the same thing. So we are done with finding the function, the sum of the function piecewisely. We are required to find the domain. The domain will be the domain of f plus g is equals to writing. You will take the union of this intervals, the union of this and this. All right, we take the union. In that case, we shall have it as minus infinity to 1 inclusive in union 1 to 2 union 2 to infinity. Can you see that? So that is it. And if you observe carefully, you will just discover that this first two interval can be summarized as minus infinity to 2. All right, the union this, and everything will break down to minus infinity to infinity. So this is the domain of the sum f plus g. So we're done with finding the function in piecewise form, which is this you are seeing here. and its domain. Very, very important. Please, you should take your time to go through this video because it's very important when dealing with limits. We shall come across this concept again when dealing with limits. And if you don't know how to break a domain, break up domain in order to define the function piecewisely, it will be a major problem. All right. So please take your time to go through this video carefully so you can get a proper grasp of what I'm explaining to you. So we're done with that one. We go over to the next, looking for the difference. So in finding the difference, we shall not have any difficulty because the domains are essentially the same as in the sum. All right. And when defining sum of function, the domain of the sum f plus g is equals to the domain of the difference f minus g, and also equals to the domain of the product f times g. All right. Is equal to the domain of a quotient, but we have to be careful when we come to quotient because we have to consider the denominator. It's a scenario whereby the denominator function value will not give a zero that will make give a value that will make the expression to be undefined. All right, so we have to consider that case. So when considering quotient, we have to be a bit careful. So we are not giving any problem regarding quotient. So let's leave that matter. Go over to getting the difference. Let's get the difference. All right, it's very easy now. Now f minus g of x is easy to guess now. So instead of writing, let's come to this part. Let me show you. Instead of writing, excuse me, sorry for that. Instead of writing this, can you see that? I'll put f minus g in the place of f plus g. And in the definition, we'll be having f of x minus g of s instead of f of s plus g of x. All right, that means there will be 1 minus x minus 0, and that will give me 1 minus x. All right, so in that case I can come here and write 1 minus s for all x that are elements of, let's go there again, elements of minus infinity to 1 inclusively, minus infinity to 1 inclusive. All right, so we're done with that one. On the second one, let's go to the second one. Look at it here. Can you see that? All s in this domain. Now, as usual, instead of f plus g, we'll be having f minus g. And what is the result? It ought to be 2s minus 1 minus 0. And that will give us this 2s minus 1. All right. So in that case, excuse me, let me remove this thing from here. This thing can interrupt the work. Look at it, has interrupted the work. Sorry for that. Sorry for that. Very, very sorry for that. All right. So we have this. So in the place of this plus, we shall have minus negative. All right. So I can come over here and write 2x minus 1 for all x coming from the interval 1 to 2. Can you see that? Then lastly, we can come here and write, that is the last one. Here is the last one now. Look at it here. Can you see that? So this one will be a bit different because in place of this plus, I'll be putting minus. So when I do that, I'll be having 2x minus 1 minus minus 1. And that will give us just 2x as a result. So in this interval, the function value is 2x. All right. So I can come here and write 2x for all x in the interval 2 to infinity. Let me be sure of that. All right. So that is how the difference of the function is defined. Also, the domain remains the same as the one of sum. Now, domain of f minus g is equals to the domain of the sum f plus g. And what do we derive for it? Minus infinity to infinity. All right, so we're done with solving this problem. So the product is still the same thing, but in case of product, we shall be having special values for the function because of the zero. There is a possible value of the function. Let's look at it together. That is f plus g of x is defined the same way using the same domain. Now, in this case, instead of writing f minus g or f plus g, we'll be writing f times g. All right. That is, if we have something of this, we can interpret it as f of x times g of s. Can you see that? Now, don't forget, the first domain we considered was minus all x coming from minus infinity to 1 inclusive, all right? Now, what was f of s in this domain? F of s was obtained to be, let's go back again, was this expression 1 minus s. Can you see that? And g of s is 0. So in this case, we shall be having 1 minus x times 0, and that will give us 0. So I can put 0 here as the first value. So for the second one, the second domain we are considering is 1 to 2 exclusive. So we're looking at all s that are in this interval 1 to 2. And what was the value? Let's look at what we had when considering that interval. Okay, look at it here. So it will still be multiplication by 0. That is, we have 2s minus 1 times 0. And that will give us 0, right? So I can come here and write 0 here also for that. Then lastly, the last interval we're looking at all s that are coming from 2 to infinity. So what do we have for that particular interval? What do we obtained? Here's it again. That is 2 to infinity. Where are you? Sorry. Okay, look at it here. Can you see that? Now, we shall be multiplying, since we are considering product, we shall be multiplying 2x minus 1 and minus 1. And when you multiply 2x minus 1 times minus 1, you will get 1 minus 2x. So in that case, I can come here and write 1 minus 2x. All right? For all s in this. So we are done with defining the product. Can you see that? So we are done with defining the products. Now, if you observe carefully, you see that these two scenarios, they have the same, these two you see here, they have the same value on the interval. So this interval can be written, this function can be also written as, you write it as 0. Now, taking the union of these two intervals, we shall have it as, for all s coming from, we have minus infinity to 1 union 1 to 2. All right, and that will give us minus infinity to 2. So instead of writing that, let me just put down the results. No need to write the expression of the union. So taking the union of these two intervals, minus infinity to 1 inclusive, 1 to 2 exclusive, we shall have our result as minus infinity to 2. Can you see that? So that summarizes for this two case. Then lastly, we have 1 minus 2x for all s that are coming from 2 to infinity. So we are done with finding the function f plus g, f minus g, and f g. One thing you should know that these functions have the same domain. All right, they have the same domain. It is only slightly different when it comes to division and composition, which we shall consider shortly. So we're done with finding this particular problem. So let's go over to the next part of the problem. The next part says form the composition f composed with g and give the domain. All right. Now, before you form a composition, now what is a composition? A composition is a function that take into operation the duty of two functions. Like now, f equals g here. I mean this. Let me show you. I'm talking about this. Can you see that? We read it f equals g, or you say f is composed with g. Whichever you want to read it is the same thing. Now, to find the composition, you must determine the domain of the two functions. For example, let me show you what I mean by that. This is number 2, all right? We want to find f circle g. Now, how is this defined first? You must know how this is defined. This is defined by writing f of g of x. That is, this f circle g is a unique function that works as follows. F circle g takes x and assigns to it the number g of x, such that g of x is in the domain of f, and then assigns to g of x the number f of g of x. I repeat once again. I said f circle g is a unique function that works as follows. It takes x in the domain of g and assigns the number g of x such that g of x is in the domain of f. That must be. In fact, f circle g will escape all x such that g of x will not be in the domain of f. F circle g will escape such x. It will abandon such x's. All right. It only takes into account such x that is, it will take x to g of s so that the value g of s will be in the domain of the function f. That is how this composition f circle g works. So when dealing with composition, it is essential to look for the domain first and look for the qualified candidates in the domain. So let's work as follows. I believe you will get it in the process of explanation. Now, in the problem, we are given the first a is f of s equals to square root of 1 minus s squared. We are given f of x equals to square root of 1 minus s squared, right? I'm also given g of x to be equal to, what is g of x here? Cos 2x. All right. Now, we are to find this, all right? Now, to find this, observe that g of s is to be in the domain of f. Now, if g of s should be in the domain of f, in other words, look at what I'm going to talk about. This g of s is supposed to take the position of x here, all right? And for that to be, it must accept values such that 1 minus s squared will be bigger than or equal to 0. Are you getting me? G of s must accept values such that 1 minus s squared will be bigger than or equal to 0, because only then is the radicand, that is the square root of 1 minus s squared, defined. So the values of g of s, now let's look at it carefully. This function you see here, what is the maximum value of this function? Well, the maximum value of this function is minus 1. And the limit of this function cos 2x is minus 1 and 1. That is the limit. That is, minus 1 is less than or equals to cos 2x, and that is less than or equals to 1. All right? So that is the possible value. In other words, it will only take value between minus 1 and 1. And since it will take value between minus 1 and 1, all the x's that guarantees that are good qualified candidates. Because if you put any value between minus 1 and 1 in this expression, it will make the expression defined. So in such a case, we can conveniently look for the composition. So we can say, therefore, f circle g of x is equal to f of g of x, and that can be written as the square root of 1 minus g of x squared, according to the definition of f, all right? And this can be written in turn as 1 minus, now where is my g of s? Is cos 2x, so I can write cos squared 2x. Can you see that? And from basic trigonometry, this can be simplified as writing sine squared 2x. And the result of this is sine what? 2x. which can also be written as 2 sine x cos s. And this is the composition of f and g in this particular scenario. So you take your time, go through this problem very well. I will leave the last as an exercise. All right, it's still the same reasoning process. Very, very easy. It's the same reasoning process. So you consider it, do the last as an exercise. Be careful when making choice. You have to look for those x's that will enable g of s to be in the domain of f. All right. So all other s6 should be discarded. So those x's that will enable g of s to be in the domain of f will be considered as a domain of the composition. All right, so these are to solve this particular problem. So you take your time, go through it carefully. I strongly advise you go through it once, twice, and try so that you can get a proper grasp of what I've explained. All right, so have a good day. I've spent too much time in this video. We'll see you at that time. Thank you very much for paying attention. I love you all. Also consider meeting me or reaching out to me if you want the service of a private online math tutoring service. If you are interested in such a service, be very free to get across to me because I render exclusive service when it comes to this aspect. Thank you very much for your attention. I will see you in our next video.